A very good morning, good afternoon and good evening to all the candidates and the participants for this NPTEL MOOC course, the title of which is Application of Forecasting, Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as you can recollect, the course has basically three main topics. The first one being forecasting and averaging techniques, second one being regression models, and third is time series models. And as we continue in the third week, so the main focus is basically the first part, which is averaging and forecasting techniques. And this is third week, 13th lecture, which is basically the third lecture in the third week, and with 3 lectures we would be wrapping up the third week. And the topics which we will cover is basically the coverage for this lecture is exponential smoothing single adaptive parameter, which we are discussing, the exponential smoothing concept of multiple adaptive parameter, and examples of forecasting. So, if you can recollect, in the 12th lecture we were discussing the concept of exponential smoothing, and the idea was on two fronts. Number one, where there is only one parameter for non-adaptive one, and in the other case being non-adaptive for multi-parameter. Now, as you can recollect, and what I have been saying time and again, the parameters would be chosen according to the fact that you want to minimize the error. Now, when it comes to the error or the metric based on which you are trying to find the best model or optimize the model would be based on the fact, I am repeating the matrix. So, it can be the mean squared error, it can be absolute error, mean absolute error, it can be weighted mean square error, it can be weighted absolute error, it can be percentage error, it can be weighted percentage error, the U statistic. There are other parameters also, but for the time being these 5 to 6 this metric, not the parameters, are more than sufficient to have a good grasp and understanding of the different forecasting models. Now, when we were discussing in the last class the concept of one parameter, it was that there is alpha, and the alpha is basically the weight which you are giving to for yt, which is standing today, and 1 minus alpha is the weight we are giving to ft, which is the forecasted value for today. Based on alpha and the yt value and ft value, you find out the forecasted value for the next period, which is t plus 1. Similarly, when we go to the concept of multi-parameter, you are assigning parameters as alpha 1 for yt, alpha 2 for ft, alpha 3 for yt minus 1 and alpha 4 for ft minus 1. And based on these assigned parameters, where it should be remembered the sum of the parameters equal to 1, that is point 1, and point number 2 is the fact that the parameters should be chosen, and rightly so, because based on the practicality it should be that alpha 1, which is basically for y1, is greater than equal to alpha 2, which is for f1, which is also greater than equal to alpha 3, which is for yt minus 1, and which is greater than equal to alpha 4, which is for ft minus 1. And subsequently, you can have more than 4 parameters, it will be 6, like alpha 1 to alpha 6, corresponding to the parameters which you will assign for yt, ft, yt minus 1, ft minus 1, yt minus 2, ft minus 2. Now, if you remember, if you have seen that depending on the choice of the parameters, like it can be 10%, 20%, 30%, and it can go to 90% and more higher values, we chose that set of parameters such that we are able to minimize the error. Similarly, the choice of alpha 1, alpha 2, alpha 3, alpha 4 for one of the examples solved was taken in 3 different sets, and we chose the one for which the error was being minimized. Now, the question which I did answer was that how we can solve this in optimization problem. I said that is not the part and parcel of this course. So, we are just utilizing the simple Excel sheet to solve the problem, because that will be much easier for all of the participants and candidates who are taking this course. Now, as you can see, the coverage would basically be now adaptive parameter. So, adaptive parameter we will consider one parameter, and it can be extended to multiple adaptive parameter. Now, what I mean by adaptive parameter is like this. I will start writing, but let me first explain. So, the adaptive parameters would be denoted as alpha 1 suffix t, which is basically the adaptive parameter for yt. Similarly, if it is alpha 2 suffix t, it is basically the adaptive parameter for ft. And corresponding to the fact that we will follow this procedure, that we will assign parameters, adaptive parameters, as alpha 3 t and not t minus 1. It is alpha 3 t would be the parameter which is assigned to y t minus 1, and corresponding to the last parameter, if there are 4 parameters, it will be alpha 4 t, which would be the parameter, adaptive parameter assigned to y f t minus 1. And obviously, the main focus remains minimize the error or consider this matrix which we have discussed, and we can utilize simple optimization technique to solve it. But for our problem, we will use simple Excel sheet as I have shown, and I will solve it accordingly as we proceed. Now, what are the nomenclature? Nomenclature exactly the same. There is no change. Apart from that, we are now assigning a suffix t to these parameters. So, we proceed in the similar way by first defining the variables and the parameters. Even though it is a repetition, but do understand that repeating in time again for in the context of the problem would make things much more easier for me to explain and much more easier for all the candidates and the participants who are taking this course. So, the first variable is yt, which is the actual value for the tth time. The next one is basically ft, which is basically the forecasted value for time t. Then you have basically the error as usual, which is et, which is the difference between yt minus ft. Now, we will add 2 new ideas or variables in this concept. One is basically termed as the smoothed error, which is given by the symbol a suffix t, and the next one would basically be the absolute smoothed error, which will be given by the variable m suffix t. What are these? I will come to that within few minutes. And the corresponding parameter, adaptive parameter, which will be for the next instant, which is for t plus 1 when we move one step forward, would basically depend on the values of at and mt, which is smoothed error and absolute smoothed error. Now, there is another thing which you can see, and I will mark in dark green, is basically the parameter beta. So, beta is basically the parameter which is being assigned not to the weightages with corresponding to f and y, but is basically the weightages which is being assigned to the error based on the fact that you are trying to utilize at and mt. I am using the suffix just for the explanation as we proceed with the problem. The suffix, whether it is t minus 1 or t minus 2 or t plus 1, t plus 2, would be made much clearer as the problem proceeds. Now, the smoothed error basically means that you are trying to, so there is, to take one step backward, is that error is there, and obviously error is the difference between the actual value and the forecasted value. Now, as we proceed, the actual value fluctuates, and obviously it can have effect where the forecasting value also fluctuates, such that in the end the error slowly starts increasing. That is possible because there is randomness in the whole system, you are taking actual values from application. Now, the smoothened error actually means you want to try to bring down the fluctuations of the error and smoothen it out. Now, if you remember in the theoretical sense, we have mentioned that the error has the mean value of 0, error has a variance. In very simple terms, the variance should be 1, but in general sense it will basically be by given by sigma square, which is the variance with a suffix epsilon or e, which corresponds to the variability of the error. And also a third point was mentioned, that it is normally distributed, the error, with the corresponding mean of 0 and the corresponding variance of 1 or sigma square, as the case is. Now, this third one is not very strong, in the sense you can have any other type of distribution, and we will see that later on in regression models, that we would be utilizing some other assumptions for the distribution as such. The first two, which is error expected value is 0 and variability be constant either as 1 or sigma square, would be true. But later on, when we go into the realm of time series, this second assumption of variability being fixed will also not be considered, because there we will consider different type of arch-Garch models accordingly. So, if I consider the concept of smoothened error, which is coming in the fact of AT, so I will use the blue color. So, AT basically would be given by beta, beta I marked in green, so I will use the green color, multiplied by the error, which I am using the light green, and I am following the color combination which I have already marked. So, there is no confusion and the continuity of the discussion and the flow of the logic is there. So, plus I will use the plus sign as in black. So, this equality should also be in black, and the other terms would be 1 minus beta. So, beta is again dark green, multiplied by A t minus 1. Now, A t minus 1 basically we have to start, when you are starting, you have to start with an assumed value, and based on that the error fluctuation was even smoothened out. So, if I draw the diagram in the theoretical sense for the error, actually if this is the 0 value along the x axis and along the y axis I am plotting the error fluctuation can be like this theoretically, which means the mean value is 0. And if I consider the other two assumptions of mean variance being 1 or sigma square or normal distribution also be true, then the error term, here I will use the green color because it is basically for the error. So, if it is normal distribution, mean value 0, it will look like this. So, this is for, say for example, for time period t is equal to t1, capital T1, whatever it is, and if I consider the error term for another time period t2, again the mean values remain same and the variability also same. So, if I consider these two distributions which are normal, the mean value is fixed, both same, which is 0, and variability also same. So, this is for time period as given for t is equal to t2. I am using capital T2 just for to make the difference. Obviously, I can use small t1 also and small t2 also. While in the case for the absolute smoothened error, you are basically trying to find out that if there is some aberrations or higher or lower fluctuations for the error, it can be possible due to some reason the white noise, the error suddenly increases or suddenly decreases. In order to basically smoothen the error using the absolute terms, we want to basically be sure that it is mean value is basically brought down to 0 as close as possible. And based on the smoothened error and the absolute smoothened error, their ratio, based on as of today, which is AT by MT, mod of that value would give me the next value of the adaptive parameter, which is denoted by alpha suffix t plus 1. Now, the question may arise, which I will come later on in detailed explanation, what will happen if there are more than one number of adaptive parameter? They would be calculated accordingly such that they will be denoted by alpha 1 suffix t plus 1, alpha 2 suffix t plus 2, alpha 3 suffix t plus sorry, it is alpha, again I will repeat, it is alpha 1 alpha with a suffix 1, alpha 1 t plus 1, alpha 2 t plus 1, alpha 3 t plus 1 and alpha 4 t plus 1. Then when I go to the next value based on all these alpha 1 t plus 1, alpha 2 t plus 1, alpha 3 t plus 1, alpha 4 t plus 1, I will find out the corresponding values of alpha 1, 2, 3, 4, but for the next time period such that for all these adaptive parameters the time suffix would now be t plus 2 and we can proceed. Now, we should choose alpha and beta in such a way. Number 1, beta would always be between 0 and 1, we have to assume one starting value, and the idea remains that the sum of the weights which we consider, which is alpha t plus 1 minus alpha t, which are the two parameters, consider this only one parameter because the sum is 1, that will continue remain to hold true. Similarly, when I come to the adaptive models, again the idea of alpha 1 suffix t, alpha 2 suffix t, alpha 3 suffix t, alpha 4 suffix t, sum of that should be 1 and obviously betas would be chosen accordingly as for the starting value. And the main idea being, again I am stating, to minimize the metric, which can be sum of the squares, then can be mean square error, it can be U statistics, it can be MAPE and all these things which we have already mentioned time and again. Now, let us do a simple problem in the similar manner as we have done. So, this is problem number 12 and specific to the single adaptive parameter. So, in the first column, I will use the light green one. So, the first column you have the month, second column you have YT, third column you have FT, fourth column you have ET, ET is the error, fifth, sixth, seventh and eighth are the corresponding values for AT, MT, alpha, beta. Now, remember one thing, beta would be fixed accordingly to the fact that it is between 0 and 1. That is point 1. Point number 2 is that for the starting value, if you see, I have marked some of these numeric values as blue, because those are the starting values based on which we will start the problem to solve it. So, we will consider the first time period error January is 0, that means we are considering YT and FT are exactly the same, hence ET is 0. If ET is 0, based on the fact that you are trying to utilize for AT, AT will also be 0. Now, also we consider that today's actual value, which is YT, would be the forecasted value for next time period, which is FT plus 1. Hence, the 200 value which you see as the first value in the third column for FT is 200, that is why it is marked as blue. Now, what we will do is that we will try utilizing the formula accordingly. So, if I basically go back to solving the problem and considering that we need to solve the problem, I will open the Excel sheet. So, give me 1 minute and try to copy these values and utilize this formula accordingly. So, just I am not removing this slide, I will basically go to the Excel sheet in order to solve, and I will zoom in a little bit. So, the values which I have would be month Y, F, E, A, M. So, this is month here, then you have y. I am not writing the suffix. If you want for more clarity, I will do it. So this is yt. The next value was basically ft. The next value, if you see, was et, which is the error. Then you have at. Then you have mt. Then you have alpha t, and finally you have beta. So let me write down the values. Basically it's from January to February. So I'll write it Jan, Feb, March, April, May, June, July, August, September, October, November, December. And the values which you have, I'll try to copy if it is possible. Let me check. No, I have to. So let me do it. It's 200, 135, 195, 200, 135, 195, then 197.5, 310, 197.5, 310. Then is 175, 155, 175, 155, which is for July, 130, 220 is for September, then 270, 277.5, 277.5, and November being 235. So December value is not there, so I won't copy. Now let us write down these. So the value which is here, if I consider this one, and I will mark it in blue because that was marked in blue in order for no confusion being there, which is the fact that we are taking ft plus 1 based on the fact that yt would be the best value to predict ft plus 1. That is why it is blue, if you can see. And this value of at would be 0. I will mark in blue bold, and value of, so let us proceed accordingly, and I will start with, say for example 0.2 for alpha, and I will consider a beta value of, say for example 0.2. It was not mentioned there, but to make it more clear we will consider this. Now we will copy the formula such that we are, so I will switch between the Excel sheet and the PPT file. So please follow me such that there is no confusion from any of the students or participants who are attending this course, and also I keep a parity and the flow is continued. Rather than copy pasting, I will just switch them accordingly. So the first term which I have is basically the error, and error, if I consider, it is basically there given as 0. So error would be 0. So at was 0 and alpha was given. So the first fact is the next period at. So I have at minus 1. I am trying to basically find out at next term, which is equal to beta into et. So beta is this into et, which is 0 plus 1 minus beta multiplied by at minus 1. At minus 1 is 0. So you have the value as found out. So let me double check. So this is beta et plus basically 1 minus this and at. So 80 of this term. So obviously, yes, this is a question. So if I consider, so this would basically become my so let me, so it will be beta t into et. Et now is not dt, is basically d3, and the value of 1 minus h remains as 1 minus 0.2, and the error would basically be given by the fact, let me check just 1 minute, et and at minus 1, et and at minus 1, perfect. So 1 minute. So let me clarify if I am missing something. Error is this done. So now when I go to a to find out alpha t, so alpha no, I am trying to find out at first. Sorry. So at would be this, would be beta. So the calculation in this G3 cell is not correct. Is 80, next term would be beta into et plus 1 minus beta into at minus 1, which is 0. Done. So now once at is done, mt has to be found out. Mt would be equal to the fact, it is equal to beta t into mod. So it will be absolute value of et, ABES, which is absolute value for this, plus 1 minus beta multiplied by mt minus 1. So mt minus 1 has to be given from here. So I will consider for the time being as 0. So in this formula, beta remains fixed. So this error is done in this formula. Beta, which is in H2, is fixed. This place is not changing. So it is $$ for this, $$ for this. And if I go back, it's $$ for this one, for H2 value. Now I want to find out alpha t plus 1 would be absolute value for the value of at and mt. So obviously at, mt are the pass values. So if I consider, so I have to consider some mt value. So this becomes at being one value being at being E2, and mt has to be put. So it cannot be 0. So I will basically consider a value of, say for example, 1 is equal to absolute by et divided by 80, so it is 0. So say for example, if I change for the time being, change, so you will see the values will be changed. So this is a lengthy problem. So I will proceed accordingly, double check the calculations and consider this Excel sheet would be utilized such that all the recordings of this Excel sheet, how the calculations are being done, will be shared in the video, and obviously any updation which is to be done will definitely be done in the PPT file. Thank you very much and have a nice day.